Kia ora Year 11 and 12. Here are some questions about logs from Assignment 4 2019. So just two little questions, but two that caused a little bit of trouble in the assignment, which really is going to be back with you soon. I'm hoping to finish marking it tonight. So here's the first one. It's looking at rearranging it so that y is the subject. So we're given this equation, x is equal to the natural log of 1 minus y minus the natural log of y. And we're told that y is between 0 and 1. Now, it has to be between 0 and 1 because we have to have the log of a positive number. So that all makes sense. And we need to show that we can write y as this. So there are a couple of ways to do this, but I'm going to do it the most obvious way and then use a useful method of forcing something into the form that we want. So we'll start by rewriting this. X is equal to the natural log of 1 minus y over y. Now, this was pretty well done. What do I do now? Well, I need to undo the natural log, so e to the power of both sides. So e to the power of x is equal to 1 minus y over y. We're making y the subject, so we're going to multiply that fraction through and get y e to the power of x is equal to 1 minus y. And now we collect up all of the y terms on one side. So y e to the power of x plus y is equal to 1. Factorising gives me y times e to the power of x plus 1 equals 1. And now I can divide through and I get 1 over e to the power of x plus 1. So we're feeling quite good. And then we look back at the top and we see that actually we need to get it with all these negative x's in it, right? So our goal is to show this, that it's equal to e to the negative x over e to the negative x plus 1. So if you focus on the plus ones, you're going to go wrong here. You're not going to see it. But let's write it the other way around. It's 1 over 1 plus e to the power of x. Now, think about what e to the power of x is. It's simply 1 over e to the power of x. So I can divide both the denominator and numerator by e to the power of x. It's going to give me this, 1 over e to the power of x divided by 1 over e to the power of x plus e to the x over e to the power of x. Now, it happens to be a lot like what we did in class today when we did that trig proof of the tan compound angle formula. It's the same trick, just in a totally different context. So now we get e to the negative x is equal to e to the negative x plus 1 as required. So there you go. So that's the first one. And now on to the second question. Right, it's a little bit small to see, but you've got it hopefully somewhere near you. Assignment 4. So we've got, we have to solve this equation. Log of x squared plus 1 is equal to 1 plus 2 times the natural log of x. Now we can't do much with this until we have it all as a natural log. So let's focus on how I can deal with that 1. Well, leave the left-hand side alone. 1 is equal to the natural log of e plus, here I'm going to make it log of x squared, and we're going to combine these. So our goal is to get the log of something is equal to the log of something else. So here we're just thinking of e as a constant, right? Not e to the power of something. Equating what's inside the logs, we get x squared plus 1 is equal to ex squared. And just try and turn off that silly circle on the stylus. Let's see. Now we're going to gather up like terms. We're trying to make x, we're trying to solve for x. So we're going to have x squared times 1 minus e is equal to negative 1, giving me x squared is equal to negative 1 over 1 minus e. But remember, e is 0.27 blah, blah, blah. So we've got x squared is equal to 1 over e minus 1. So x is going to be equal to the positive square root of e minus 1. So we reject the negative solution, because we need log of x, natural log of x. So we need x to be positive. So that's my exact answer, but we were asked to give it to 3 significant figures. So chucking that into your calculator gives you x is equal to 0.763, and that's to 3SF. So there you go. Thanks for watching. I will do some more complex numbers videos and trig later on this weekend.